All right, guys, it is Pancho time. We are going to be making some, waves today. Specifically, it's time to implement the logic for changing the quantity. So when I type that in, well, it shouldn't go not a number, first of all. So we might want to fix that at some point. But yeah, we wanted to contact the backend and actually change the database. Now, before I get into that stuff, we're getting a lot of junk in the trunk here. Let's quickly refresh this bad boy. Let's see here. I think it is artisan migrate fresh seed. Give us your fresh seed, artisan. And if we go back here now, yeah, we got rid of the garbage. Okay, so how are we going to accomplish this? Well, you saw me do it before, and what I did was I implemented I think it was the input event, right? So every time you press a key or you press backspace or whatever, that is going to fire an input event with the current value of the input, and then you process that, and we would process that, and we would send a request to the server, and the server would update the value, the quantity of that item. Now, here's the problem. Someone's typing numbers in. You don't want to fire off a request every time when they're typing, and then they hit the backspace a bunch of times, and it's too much. So we got some options here. We could, instead of using the input event, we could use the change event. And so they would type, nothing would happen until they clicked off of this thing. All right. And I mean, that would be okay, but I want something that's a little more responsive than that. I don't want to fire off events every button press, but at the same time, I don't want to have to wait for them to click off. What if they don't click off for a long time and they're watching some other piece of data and they're saying, it's not changing. Why isn't it changing? It's because you got to click off. I don't like it. So what we're going to do is we're going to implement a little bit of a debouncing routine so that it will basically wait after the last button press, and it'll wait until nothing has been done for 1 second or 600 milliseconds, and then it will fire the request off. It will dispatch the action. So how do you do that in JavaScript? Well, you can't just sleep. You can't block the process of a JavaScript script, because Java isn't multi-threaded. So if you block things, you're basically blocking the entire engine. You're freezing the page, essentially. So they don't like it when you do that. So what you have to do is you have to basically schedule your script to be run again at some time in the future. And you do that with a function called setInterval. You pass it a callback, and it will execute that function at some time in the future. But here's the thing. I don't like those callback bullshits, because it gets nasty quickly. You get something called callback hell, and it's dumb. So we are going to wrap that up in a promise, and we are going to use async await magics to make it all very sexy. It's going to be a good time. This is something that I just looked into recently, because I've always had the idea, set interval is a function you use every now and then, but it doesn't support async await syntax. So I'm like, how would I do it? There's got to be a way to wrap it up, and there is, and I did it, and it was cool, and now I'm going to share with you guys. So that was a bit of a spiel, but we are ready to go. Also, I'm going to look into this not a number thing, because that's not cool. But let's go. Where do I want to start here? Let's start with a little experiment. Let me show you guys what I mean by that async await machinery that we're going to implement. So in core, let's create a new TypeScript file, and we're going to call it sleep. And this is going to implement our asynchronous sleep function, which is going to be running, set interval, or set a timeout, not interval. Interval schedules something to be run every second or every 100 milliseconds. Set timeout just schedules something to be run once in the future. So that's an important little distinction. So we're going to export class. No, we don't need a class. It should just be like a function. Async function sleep. Now it's going to take in obviously number of milliseconds to sleep for. And we'll start that off here. Okay, so async function. Generally, what you do is you, in an async function, you call await on another async function. And what that does under the hood is it transforms that into a promise. So async function, if you try to tell async function is going to return a number, it's going to be very mad at you because it's going to say, you know, it's an async function. It has to return a promise. So you can return a promise by awaiting another async function, but you could just manually return, you could create a promise and return it. And that's what we're going to do. So how do we do it? Return new promise. Now there isn't any, like this process that we're doing, this sleep process, it doesn't produce any result. So the promise isn't going to wrap any data. But we need to pass it, you know, the actual function that it is going to call when it is resolved. So resolve, set timeout, resolve, number of milliseconds. So what this is promises can be chained, and sometime in the future, it'll be determined what process is going to happen after this sleep process, and we should execute that process after the sleep, which is the set timeout. And that's how promises basically work. If you're not familiar with it, it's probably a little difficult to wrap your head around, but you know what? Don't worry about it if you are interested in it. I suggest you look it up. You should look it up in the context of the history of JavaScript. So first you should understand, you know, callback hell, and then you can understand why promises were created to solve the problem of callback hell. And then you can look into what async and await does to the promise syntax to make it a lot sexier. But anyways, so here's our function to sleep. It's very simple. Let's go into, whoa, losing my voice here. Voice is changing, a little late, but you know, better late than never, I guess. Card text. Okay, so in here, let's create just a little test section. We want v button, and what else do we want here? We'll do a div. All right, so we're gonna do a little test here just to test out our code. We're gonna import sleep from, and I believe this would be slash back core slash sleep. So I believe this is something that I can do. And down here, let us create a little test function. We will call it, I don't know, test action. Doesn't matter. Does not matter. Okay, so what are we going to do here? Well, we need a little bit of test data. So let's call this one test flag. And initially, yeah, it should be false. Okay. So in test action, what we're going to do is we are going to await sleep 800 milliseconds. And after that time, we are going to set test flag equal to true. No. This dot test flag equal to true. All right. Now up in here, we want to do click test action. So here we set the event to be happening sometime in the future. And we do test flag question mark on off. All right. So very simple test here. Nothing too complicated. Let us see if I can. No, why are you? Oh, okay, well, yeah. You know, you got me. You got me. We need our async. You know what Chili always says? Two in the pink, one in the async. All right, so we set, and if we wait, on. Yeah. So after a short delay turns on. So it's working, right? So now we can have this syntax. So instead of, having a syntax like set, what would it be? I keep forgetting. Timeout. And then in here you'd have the function name. So we would do, function blah. This dot test flag is equal to false. And then in here you'd have the number of milliseconds, which are 800. So instead of this syntax, and if you had multiple sleeps, you would have multiple set timeouts nested within each other. Instead of that, you have a single clear line of execution. I'm going to wait, and I'm going to do something. And that's what I want. That's what I like. Now, here's the thing. So for what we want to do, let's go back to this here. If the user hits a button, then we want to start this set timeout. Give it a delay of 1 second or whatever. But if the user hits the button again before that timeout has completed, we want to cancel that timeout and set a new timeout. You know what I'm saying? So as long as they keep typing, we shouldn't be doing anything. We should cancel the previous scheduled timeout and start a new one again for 1 second in the future. So we need a way of canceling this set timeout, and JavaScript has that. We just need a way of doing it from the outside in a sexy manner. So allow me to introduce to you guys my little design for this. We are going to export class kill switch, and kill switch, probably want one of those. All right, private timeout ID. It can be a number or it can be null, and it is initially equal to null. Cool. We got a couple functions here. We're gonna a function to bind this kill switch to a specific timeout. Timeout ID, which is a number, and this dot timeout ID is equal to timeout ID. Obviously. Okay, cool. What else? Let's have a function to clear the kill switch. If it is set the target a specific timeout ID, we can unset that if we want to for some reason. It's equal to null. And last, but definitely not least, the function to actually kill the timeout. And so if this dot timeout ID is not equal to null, we actually have a timeout that we're targeting, then we call clear timeout. That is a function that is, provided to scripts running in the browser. And then we'll clear the timeout, and then we'll also clear that ID from this kill switch. So here we go. Simple kill switch. Now what do we do here? In sleep, we will take an optional parameter, kill switch. It's optional, so it can be undefined. And what we do now is, depending on whether we have a kill switch, we're going to do a different thing. So why did I not put a space in this if there? That doesn't make any sense. If kill switch is not equal to null, remember, this is not a strict comparison, so that includes undefined. This is my preferred way of checking for undefined, by the way, because it also checks for null in case some way that happened. Shouldn't be possible. But anyways, return new, promise. Why do you say PR void? Don't know what that means. Anyways, it's fine. So we're going to resolve. Take in the resolve thing, and we're going to do kill switch.bind. So the ID of the timeout ID is returned when you call set timeout. So we're going to bind that to the kill switch. Set timeout, resolve, number of milliseconds for the timeout, and there you have it. That's it. Might as well just put this all on one line, actually, you know, when you think about it. Else, we just do what we did before, which is, you know, we create the promise without setting the ID to anything. There you go. So now if we pass in a kill switch object, it will bind the timeout to that kill switch, and then we can use that external kill switch that was passed in. We can hold on to it and use it at a later time to cancel the timeout if we want to. So let's do a quick test of that. Here in our test area, we'll create another button, and we will call it cancel action. KILL. Okay, and down here. So now we're going to store, well, first off, we're going to import kill switch. We're also going to store a kill switch. I mean, KS is equal to new kill switch will give us that. All right. So now when we run our test action, we are going to pass in this.ks. First off, though, anytime we fire the test, we want to kill any previous scheduled timeout. So we do ks.kill. So if ks is currently bound to a timeout, it will kill that timeout. Then we schedule a new one. Let's make the timeout a little longer so that it's a little more pronounced. But let's also make a way of, you know, just prematurely canceling the action without saying another one. So we can do, I think it was clear action was the name of the thing. That, yeah, cancel action. That's what it was. Cancel action ks.kill. There you go. Okay. So if this is all working correctly, if I click set, ks is not defined. Yeah, okay. So I forgot this. I am known to do that. All right. So we set. Probably should put it here as well. Thank you very much. Oopsie daisies. Try it again. All right. Third time's a charm. Set. Wait, and it's on. Okay. Let's try it again. Set. 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 You see, it's not firing because we keep resetting it every time we hit the button. Set. Now if we wait, it's on. Cool. Third test. Set. Kill. And no matter how long we wait, it will not go on because we have killed the timeout. So this is the machinery that we will be able to use here to debounce our inputs for when we're typing in the text area, or the text input, or whatever it's called. Text field, I think it's called. So we're going to delete the test code, and I'm going to commit. All right, now it's time to implement the backend logic here. So we need another action. Public function set quantity. It's gonna, obviously we need our request, and we need the item instance on which we are acting. So I believe this is something new that we haven't done before, but yeah, not in any of these. But yeah, we're going to specify a specific instance to work on within the route. So that'll be cool beans. We want to validate this, validate the request. What are the rules? Well, there's going to be one parameter, quantity, in the body. That's not the symbol I wanted to type. So quantity is required. It should be an integer. And let's say that you need at least one. You can't set to 0. for now. Although maybe you want 0. Man, we'll allow 0. I'll allow it. Fair enough. So no negative. You can't have negative Pepsis. That doesn't make any sense. Well, it can make sense. You know, you owe someone a Pepsi, but it's not a case that we want to support in Pantrio. Let's just put it that way. Update. So we're going to update the instance that we have, and we can just update it with a key value pair. So here's a cool thing. We could do, we could create an array that has quantity, and the value is the quantity in the request. But we can also just do request only quantity. And this will return an array where the key name is quantity and the value is the value of quantity in the request. And then pass that into here. So we got this nice syntax here. I love it. I love the Laravel sexiness. It gets me up in the morning, if you know what I mean. All right. Now, here's the interesting part in the API. So instances, but we can do a little cool stuff here. Put a parameter in the URL. So this will change. It'll be a number, and that number will be the ID of the instance. Laravel will see that you have a variable, an input to set quantity named instance, which is the same as the name of this parameter. It will bind that to this, but the parameter in here will be a number, but this isn't a number, it's an item instance. Laravel will see that and it'll say, okay, that number must be the ID of the item instance, and it will grab that thing from the database, that row from the database, and hydrate it and give it to you in here so that you can work on it. It's called route model binding, and it is also sexy. It is also sexy. Set quantity. Here you go. Okay, so now this should be good. So let's get the initial state. And look at our instances. So instance 1 is item 1 in storage area 1. Quantity is 9. So let's go instances 1 post body quantity. Obviously. Send. Good. Okay. We did not returning any data, so we don't expect anything. Now we go back to get that initial state. And if we look at item instance 1, it now has 420 quantity, and we have achieved success, my friends. All right, so the back end should be ready to go now. We just got to look into the front end. So in Pantrio.ts, so we already got a mutation here. So now we just got to add an action. So action. Async set instance quantity payload. What is our payload going to be? Well, we need instance, which is an item instance, and we need the quantity, which is a number. Seems simple enough to me. We will await. You know what? Post. I'm just thinking here now. Post is like for posting something new, but if we want to modify something existing, it's actually more idiomatic to use patch. So let's set this route to use patch, and then in here, axios.patch. Now we need. Let me see here. How does the URLs look now when we're working with them? Where add item instance to area. Where's my here's a post. Instances. Okay. So we want instances / interpolate instance.id. So put our item instance ID. You did it again, didn't you, Chili? You did it again. Back at it with the vans. Damn, Daniel. Okay. I'm just thinking here now. This isn't a very good URI. So instances, what instance? But if we patch to that, it's like we're patching the entire instance. But really, we're only patching the quantity. So let's do instances, instance ID, quantity. We're just, we're patching it live here. Quantity. Okay. So that's making a little more sense for me. And then we need the data, which is going to be an array, not an array, a JavaScript object, in which quantity is payload.quantity. All right. That's good. And then after that, we do this dot underscore set instance quantity, and the payload, just a payload, right? It's just this payload is going to be forwarded to here. And I believe that that should be all that we need here. So we have our store set up. Now, let's go to the presentation layer. What are we going to do? Well, let's create the quantity change kill switch, which is equal to new kill switch. Beautiful. It automatically imported that for us. You gotta love it. You love to see it. Async. Quantity changed. We have to take in the instance, and we got to take in the quantity. Instance and quantity. Sure. This. That. Quantity changed kill switch dot kill. First off, kill any existing pending quantity change. Then await. Sleep. Can I use SLEE? Yeah. It didn't import it. Why didn't it import this one? Alt enter. Good. Okay. So we will be sleeping for, let's do debouncing of 800 milliseconds. That seems good to me. This dot, pass in the kill switch to bind, and then we will do another await. We will await this dot pantrio module dot set instance quantity, and the payload will just be instance quantity. I keep doing that. Quantity. All right. Actually, now that I look at it, quantity will pass this in directly from the function, the event. So this will be text. So we have to parse it. So quantity will be parse int qty. There we go. All right. So that should be our handler for the quantity changed event. And now let's go up into here. Where is my quantity? There's a qty. I see it. Input. I synced it. So here, inst is our instance. So quantity changed. Pass it the instance. Pass it the event parameter. And that should be it. Error. Module not found. Cannot resolve. All right. Well, you know how it is. I gotta fix this at some point. But this, like this default, the default paths that they're giving us, they're not correct. And I can mess around with the config a little bit and change it, I believe. So I'll have to do that eventually. Until then, we just gotta manually put in this dot. So I should do that. If I do it relative to this path here, everything works fine. Let's try it again. Oh, yeah, it's working now. Okay, good. All right. So, how do we want to test this? Let's get up our tools. Let's look at the network. So I type, then I get an event. Now you're going to see two requests firing here. One is pre-flight. There's an options request, basically. And this has to do with cores. If you don't have your things on different domains, you won't get this. But yeah, it's just something to be aware of. But yeah, when we hit it, after a short delay, we get a request. If we keep typing, it will not do the request until we're finished, and then it'll done. So the debouncing works. Next question, does it get saved into the database? Well, let's just refresh here. And yeah, it does get saved because when we reload the page, we get the value we had previously. And if we look at awesome copper lamp, we see, yeah, it is definitely also working in the reactivity. Well, we shouldn't say that until we've actually done it online here. Yeah, it works. But it also only affects here after the debouncing has happened. So if you quickly type in something and you look down here, hasn't changed yet until it registers in the database and has been confirmed, and then the rest of the application changes, which is what I want. So that's great. Now, the last thing I want to look at, okay, so two things. First off, I want to do the same when I change this one. You'll notice nothing happens because I haven't wired that up. So I want to wire this up. The other thing I want to do, yeah, so I wanted to handle the case when it's empty. So let's do that first. What we can do is in the handler, where is it? Here it is. If qty is an empty string, we could do empty string, but we could also do const quantity is equal to parse int qty. Okay, so we'll do that ahead of time. Then, if is nan quantity, return. Don't do anything. We're done here. If not, then we can just use that quantity in here directly. So this may fix our problem. Let me check. So we type, and what is this? Awesome copper lamp again. It is being registered. If we empty it, that's interesting. It goes back to the last, right. Yeah, it's a little bit of a weird behavior. I know why it's happening. Because it's firing off events, but the last one doesn't cancel the previous ones. So the last event fired will be 1. If I delete all these, the last event fired is 1, and when it comes back, it sets the model. Yeah. So we can actually change that annoying behavior by killing before we do anything else. So if we do it like this, I just like to reload for, you know. All right, and then if we delete, nothing happens because it kills that last one. Nothing has changed here. We can type in some non-number stuff. I could set this input to be a number input, but it puts these annoying like controls on it, like up and down controls I don't like. So I'm not going to do it right now, but I might take a look at that later on. There's also a neat syntax you can use where it'll automatically parse it as a number, but I don't want to do that yet either. So we're just going to do this, and yeah, this looks good. Now, final thing, we want to do the same for the other view on the data. We want to be able to edit the data from either view. So I have to find it. It's quantity in here. Bind is value. So text field. This one. That at input equal to quantity changed inst and event. All right, and that should be it. That should also do it for this one. We're going to use the same, the same kill switch timeout for this one as for that one. I'm just thinking now, because of the way this works, if you type very fast into this input and then you type into this input right afterwards, you might cancel the change for this one. So that's something that we have to think about in the future, because that could cause like some real strange problems for our users. But I'm not going to worry about that today because, you know, this video is getting kind of long already. But anyways, let's try it out. Let's go awesome copper lamp. And we'll set that to 1666 and then change it up here. And if we refresh, yeah, okay. So I think we've done a little bit of good work today. We learned something new about, you know, async await, how to make your own async machinery, if you like. Wrap it around, you know, legacy callback code. In the next video, I'm not sure exactly what we're going to do, but I think probably we're going to continue on implementing core functionality with the ability to delete instances and areas and items. And that's the other, I mean, obviously you're going to need that ability. We don't have it yet. Once we add that, we will have, you know, the very, very bare bones of the functionality that we need. But until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button, helps a lot. And I will see you soon with some more Pantrio.